There we are, right on time, 6 o'clock. My time, Sydney time, that is. I hope it's a nice day where you are. And welcome to day 2 of the ASBU, ABU, and WorldDAB workshop, New Development for DAB Plus Systems. This is day 2. I'll just share my screen and run through a few things here. So hopefully, can everyone see that screen okay?
Yes.
Okay, great. Thank you. So today we've got more technical topics and also some discussion on how some countries are moving forward. So let's go through that. First, I'll start off with a brief run through of DAB Plus features. We're then going to throw over to Mr. Hans Wolter, Technical Director of DAB Italia, and also the Chair of the WorldDAB Spectrum Networking and Implementation Committee. And he's going to talk about DAB Plus network design with a specific focus on single frequency networks, a very, very important topic. We'll then go to Mr. Lewis Grela, Managing Director of TRedess, who will give us an update on the very latest on DAB transmitters. Then we're going to switch gears and we're going to look at initial DAB steps. First of all, we'll have Mr. Ariiho, Manager of Broadcasting Infrastructure from the Uganda Communications Commission, talking about DAB Plus adoption in Uganda and how they're moving forward. And then secondly, we will have Mr. Banda Rasheedi, General Manager of Radio Projects at the Saudi Broadcasting Authority, talking about the DAB Plus rollout in Saudi Arabia. So two very, very good examples on ways to move forward with DAB+. So at this point, I'm going to go straight into it. And we'll save our time for questions. So a couple of points. First one is videos from this webinar series will be available on Friday. The presentations will be available later today after the day's workshop. So each day we'll put out the presentations from the day we've just had. A couple of other things. Please remember, if you've got questions, use the Q&A box at the bottom of the screen. We had some very good questions yesterday, so I'm really hoping that we'll have the same today. That will be great. Okay. Get rid of that presentation. And we'll go to this one. And I'll share my screen again. Okay. Screen 2. Okay. Can everyone see that that first slide, DAB system features?
Yep.
Yep, all good. Okay, great. Let's go through this. Okay, so I'm going to talk a bit about broadcast features, a bit about receivers, and a bit about hybrid radio. So the first point here is that DAB Plus has an ensemble structure that provides a flexible way to deliver multiple services. DAB system is very versatile and can accommodate a range of services and bit rates within the overall ensemble capacity of 1.152 megabits per second. That's the typical value used. There are even variations on that if you wish to use them. Typically 18 to 24 services per ensemble, delivering crystal clear audio and also program associated data such as text and images and advanced features. Now, the first and foremost thing is radio is audio. And DAB allows broadcasters to expand their portfolios of services, offering curated, niche audio types and content to better compete with online streaming services. And here's an example from Germany with Berlin, 77 stations, local, regional and national. Just a couple are shown here. But a few more examples, and some of this was covered by Jackie yesterday, so I'm not going to dwell on it too long. There's one from Absolute, who went from 1 AM service to 10 DAB services, and managed to triple their audience in the process. Same with the BBC in the UK. They started with 4 national services on AM and FM. They now have 14 DAB services. And one from Australia, where I come from. This is Southern Cross Austereo Network, expanded from 2 FM services around the country to 14 DAB services. So they have their 2 main FM services, Hit and Triple M, and each of those have 6 additional services for niche markets. So good examples of how to expand the cover, your content offering to encourage more listeners. Of course, DAB offers flexibility in pop-up stations. We've had a few of those through the years in terms of Christmas time and Olympics or floods and things like that. Recently, we had Taylor Swift on her Eras tour, and Capital did a pop-up station while that tour was in the UK called Taylor's Version. Another one here is for the London Jazz Festival. We had Magic, had Soul Summer, and the BBC did a special jazz service during that London Jazz Festival. So good things that you can do with the flexibility of DAB. Now, we also remember that in DAB, services are listed by name and not frequency like they are in FM. Don't need to remember frequencies, just look for the name of the service you want. And this is a very easy user interface, and it encourages brand recognition. We also have the program associated data, program dynamic label segment, as it's called officially, but most people just call it text. Up to 128 characters, carrying all types of information, quite commonly things like now playing information or news headlines or weather information. And there's a couple of examples of different radios types to do that. And of course, slideshow, we have images as well, more examples of images, quite often used for album art. That's quite nice. But also for other things, it can be news, it can be a weather report or other things. It's all up to the broadcaster as to how they like to use these features. Another example there. As for the advanced features, I think service and program information is very important these days, with especially the ability to deliver service logos. We can also deliver website links, program schedules, and so forth. More on this a little bit when we talk about hybrid, because hybrid's also very good at some of these advanced service and program information aspects. We've also got service following, where links can be used to allow the listener to follow the same service in different service areas. And I've got a little example down the bottom area from my favorite services. On one area is on Ensemble 9C, and in an adjacent area is on Ensemble 8B. So you can seamlessly switch between these. Now, Lindsay Cornell from the WorldDAB Technical Committee will be talking about how to use service following tomorrow, and give some details at that point. Of course, we also have the new DAB Plus emergency warning system called the Automatic Safety Alert. This has been talked about over the last year, I suppose, with the special features that it does provide. It's used in emergencies. We live in turbulent times, and we know that listeners turn to broadcast radio in times of crisis. And the automatic safety alert was developed especially for that. It aims to protect the public during emergencies by delivering reliable safety alerts without requiring an internet connection. We know the internet often goes down, just as power also goes down in many serious crises, floods, cyclones, storms, fires. Listeners will benefit from the system that alerts them if mobile internet connections are disrupted, and the ASA operates automatically in the background through internal signaling within the DAB Plus system, and it can be adjusted to location with an accuracy of about 1 square kilometre. Now, that's very important because the previous systems used in DAB operate with the alarm announcement, and the same thing actually happens on DRM. It's just an alarm, and that alerts the entire area. So if you have a localized specific emergency, it could be a factory fire with chemical smoke or something like that, for example, then that particular emergency can be isolated by distance by the emergency services organisations and signalled so that people that don't need to know about it won't know about it, and it won't interrupt their service. So this is a very clever way of doing it. It is certainly the most advanced emergency warning system on broadcast radio. We know it works because of successful official testing at the German WorldDAB Emergency Warning Day last September, and mass production is now progressing, and we're expecting products to hit the market this summer in the European area, or European time. Of course, it's winter here in Australia, other side of the equator. But they're coming if they've not already arrived in some cases. So a very important area there. Let's quickly run through receivers. Over 150 million receivers have been sold, consumer and automotive. All sorts of receivers. Need to update that. We've got handhelds. We've got tabletops. We've got kitchen radios. We've even got radios in flashlights that you can use when you go camping, and prices down to $10 in some volumes, and that was last year. Might be even better this year. Automotive in cars, all automotive brands now support DAB+. It's mandatory for DAB+ to be included in cars in Europe and also in Saudi Arabia. We might hear a bit more about that a little later today. The fact is it's there, and it's now being rolled out as a matter of fact to all brands. And that's largely due to that European mandate, the EECC directive that was started about 5 years ago. This is a really, really good way for new countries adopting DAB to get receivers in cars before launch, so that when you get to the launch of DAB+, you already got a listening base. There's already multiple radios there waiting to receive services. Quickly turning to hybrid radio. Hybrid is the use of both DAB broadcast for audio and simple metadata like text and images, but also the use of broadband IP, typically through a mobile network, to deliver advanced metadata such as high-resolution images and other services such as analytics, possibly click-through sales to websites, alternative content, and listener feedback. It's being facilitated by three main organisations: Radio DNS, Radio Player, and Xperi. And it's now found in many major car brands. There's just a couple of them there as well, and probably should put Ford in there. That'd be another good one, and General Motors. So now the WorldDAB Automotive Workshop, which occurred last month, has a range of discussions on automotive aspects of DAB in cars. and you can get the presentations and watch the presentations as well live on video if you go to the WorldDAB website. So just to summarize now, DAB digital radio provides a wide range of advantages over traditional analog radio. It's more spectrally efficient to allow significantly more services to be provided in an area, and we often see 4, 5, 6 times the number of services, and that really captivates the audience. It really keeps people engaged with radio. Of course, it has crystal clear sound. It has text and images. It has the most advanced emergency warning system in the automatic safety alert. Those advanced features I talked about, more advanced features through hybrid radio, and receivers are widely available and at low cost. So with that point, I'll just say keep on rocking with DAB plus radio. So hopefully that's it's just a little quick update on what DAB can do, just so that we all understand how that works. So thank you for listening to that. We are now, I think, going to go to Hans. Hans a second.
Yeah.
We seem to.
Yeah.
Yes, that's better. Thank you.
Can
Are you
hear
okay
me?
with that, Hans? Yes, please. Yeah, please share your screen and over to you. Thank you very much.
Yeah. So can you see my screen?
Yeah, all good.
All good. Okay. So good morning to everybody. Thank you, Les, for your introduction. Very interesting and comprehensive. And I will go into detail about speaking a little bit about SFN, so single frequency network. That's the topic. Just wait a second. Okay, so just a few words about what I'm doing in the DAB world. So I work for the technical office of WorldDAB Italia, which is a network operator in Italy. And we are owned by 8 radio stations. So we are basically what we call in Italy a consortium. This is due to regulatory requirements, because in Italy, in order to get the usage rights for a spectrum, you need to have a consortium. So spectrum, the frequencies will not be allocated to a single user, but to a consortium. This is, of course, done in order to avoid, let's say, too much control or a monopoly. We are currently broadcasting or simulcasting 8 FM stations, which are the original stations of our owners, which are all active in the analog world. We broadcast also 8 new DAB stations provided by these owners, and also 2 services from third parties. The regulation in Italy provides for, let's say, a commercial opening. So we have to sell or make available to the market a number of slots for DAB, additional DAB stations. And for now, we have 2 customers which are external from our consortium. We run a national network, which means also that we are not doing splittings and stuff like that. So if you are broadcasting on our network, you will have just the same signal on the whole territory. And we are currently, as of yesterday, running a network with 260 transmitter sites, which is pretty significant. And this will take us later also to the SFN problems. And we provide full service. Basically, the customer gives us the audio signal, and we will manage everything from, let's say, from the radio studio to the radio receiver, basically. So we do, we look at towers, we choose the sites, we do the planning, we do the antenna systems, we plan for this. And also we run the network, so we do the monitoring and check that everything is okay. We have to do reporting to our customers. So we do a lot of stuff inside the DAB chain. Also, I'm the chairman of the SNCC, the Spectrum and Network Committee of WorldDAB, which is a very interesting committee. So if you're a WorldDAB member, of course, I pitch this committee to you. We do activities which are related to radio spectrum. We support the DAB rollout. If you're implementing DAB, you can come to the Spectra, to the committee, and we will try to support you on, let's say, practical issues like building transmitter sites, managing multiplexes, doing the audio processing. We have some experience on signal distribution and on signal monitoring and on data services. But let's move on and come to SFN, single frequency network. What is this? Of course, it means that you have a number of transmitters using the same frequency, which is, of course, if you coming from the FM world, something very different. For some people, it's also magic. And I must partially agree, because once you have implemented this, you will see very interesting effects. If you look, for example, at a very important publication for DAB planning, which is EBU 3391, basically it says SFN operations possible when you have the same signal in terms of content and frequency, and you receive this from different transmitters. You will have the possibility that the receivers actually can use this as a useful signal. And you will not have any kind of interference as long as you respect a number of parameters. So you have basically the same frequency, same content, and the magic happens. For those who are already running DAB transmissions, this is, for example, a plotting from a Chelinpun's response, where I have my office, and you can see actually there are a number of peaks. Two are very significant, and the machine is able, or the instrument is able to decode them, but we have other signals arriving. These are all DAB transmitters which arrive here at the office where I am. And basically, the receiver can use all these signals. So if one fails, nothing basically will happen. The receiver will continue to play. So there are basically three important concepts when you're talking about SFN, which is the guard interval. And if you can look at this from different perspectives, so it's an interval in time, and you can see this here also on the line. So it's 246 microseconds. And if you look at it in terms of propagation, it will be something around 74 kilometers. That's the time electromagnetic waves propagate in 246 microseconds. So why should we use SFN? And there are a lot of reasons why we should use it, in my belief, and from our experience, actually. So the first one is planning is much easier. So if you're a regulator, you would like to plan for single frequency networks, it will be easier, and it will be much more spectrum efficient, because you can use many more frequencies instead of having to stack them and create a raster in order to avoid interference. Simplicity, and this goes very much to the management of the network. So if I'm a network operator, if I have a single frequency network, I will have all my transmitters on the same frequency. I will have to tune the filters on the same frequency. It will be much easier to manage, really, from a practical point of view, this network. Also, you can optimize some aspects of the transmitters. I think Luis will go into detail of this later. You can also optimize the antenna systems for a specific channel. So there are a lot of advantages if you use SFN. You will have performance advantages. which go to coverage because you have a more uniform power distribution. Because also, and you will have also the possibility to use the reflections of the signal. You will take advantage of the multipath propagation. If you have mountains and valleys, you will see that inside the valleys, the propagation will be much better compared to analog systems. And also you will have a radius which will not need to switch to different frequencies. And what we see in Italy, where we have a lot of radio listening in cars, is that although you can implement service following features, there are still some products on the market which don't cope with this so well. So less frequencies you have, the easier you make it to radios. Of course, if you are looking at domestic receivers, this will not be a significant advantage. You have also issues related to SFN, and I will focus on this because the advantages are very evident, but there are, of course, issues, and we will try to I will try to propose some solutions to this. One issue is, of course, the regionalization. So if you need to have regional services or local services, you can't do this in SFN. This is, of course, self-evident, but it's better to say this and to be clear about this. There has been in the past some suggestions to make regional SFNs where you had basically the same multiplex broadcasted, but then in different areas, one service was added or taken out of the multiplex, but this has been basically unsuccessful as far as I know. Nobody's doing this. So I guess there are better solutions to do this. The biggest issue we have to face when we speak about single frequency networks is, of course, the self-interference. And this is where I will really focus on. Self-interference is the risk, of course, of single frequency networks. It takes us back to the guard interval. If you have signals outside the guard interval, which we talked about earlier, of course, you will have the problem that these signals will not be constructive, but destructive. Self-interference can be managed in many cases, and we have a lot of experience in this. So we have been building very extensive single frequency networks. But there are, of course, some situations where it's just impossible, and you have to cope with it. So you have to take some decisions to use or a different frequency or just to accept a certain amount of interference. So why do we have, first of all, single frequency interference? There can be a lot of things which can create this. It can be the wrong selection of some aspects of the transmitting side. It could be related to the site itself, the powers applied, the antenna system. We can have problems on warm water propagation, and these are really significant. And of course, you can also have single frequency interference created by some, let's say, technical issues. So you have some hardware, some reference which is not working, GPS not working, external references not working. You've done some calculations wrong, you made some errors, or you have problems induced by the distribution network. Maybe you have one part of your network which gets signal from satellite, another part which gets signal from radio links, another part from IP connections. You have to scale this and adapt this. So you have to be very careful about this. So the first step, of course, to mitigate any interference really is to do when you in the beginning of the network development, start immediately with an analysis of the network of the plane you're developing via software. There are a number of softwares which can do this. And with this, you can tinker with the sites, the powers, the antenna systems, and you can really also adjust a priori. So before actually running out anything, the timing settings. And this is something we are really doing a lot. And usually we really see that there is little need later once the transmitters are brought into operation to do changes. So if you do this job well, you are more than halfway through the process already. For example, here we have a short overview of an exercise we did a couple of years ago. You can see on the top of this image 4 big transmitter sites which are up in the mountains, and they serve, let's say, a very vast and flat area. And if we wanted to put into operation a transmitter, let's say, on the other side of this flat area, which is about 120 kilometers. So it's outside the guard interval, so it's not easy to synchronize this. And without any delay settings, of course, we get an interference area where reception was really bad. So we started a number of iterations of this process. And you can see in the second step already we reduced, let's say, or we increased the coverage area. The third was even a little bit better. And the last one is the one we settled. So if you carefully use the software resources, you can already, let's say, do a lot of initial work. There are some areas here where you have a certain amount of interference, but this is, let's say, we have decided that this is in areas where you have less population, so you will have mainly only in-car reception, and the reception should be actually acceptable. So we decided that this was, let's say, the best solution we could actually adopt. There are a number of rules, and these are really out of, let's say, they will sound very simple, but if you apply these rules, you will always get good results. The first one is, if possible, avoid high sides and avoid high powers. Especially, but the first one is really, the first line is the most important one, because a high side will give uncontrollable effects which are not, you cannot control to the full extent. And if you couple this with high powers, you will really get great coverage, I agree, but you will also see the signal propagating inside your single frequency network too much. Also, and this is also really a recommendation, avoid complicated antenna systems. So don't think that if you use complex systems which tilt the antenna to the right, to the left, up, down, you will really have full control. You have a certain amount of control, but you will never get miracles out of this. And even if your planning tool will show you that this might mitigate the single frequency interference, you will never have 100% accuracy in this. There will be problems related to the tower, to the cables, to the whole antenna system, and it will never perform exactly as expected. So the more simple you have your system, the more reliable will be your planning, basically. The other thing is, this is something we really saw over the time, and I call it the Wolter law, because this goes very much in controversial to, let's say, the typical broadcasting theories. If you go to low tower, you can use high power. So the old theory was also low tower, low power, high tower, high power. And this is basically the opposite. So if you go to a high tower, to a high site, settle for low power. Don't risk to get self-interference. If you look at the image here, you have, for example, what I call a low tower, high power system. This does creates coverage in an area between two cities in northern Italy. It is a very big site, basically, which provides a limited amount of coverage. So you might think it's inefficient. But if you just move the transmitter site to another place, which is a typical analog FM site, which is just 300 meters higher, even using just half the antennas and half the power will give you this sort of coverage. And you say, yeah, great, this is much better. But you see the red ring, that's the 74-kilometer area. And all the transmitters which are in the north of this area, and which will broadcast down, will become in some way or another interferent. And this is a situation where really, I go back one slide, you need to settle for a smaller coverage area. Although this might be more attractive, you will otherwise really wipe out in some places your coverage. And so you will sometimes need to settle for simpler things. This is actually an image of this low tower, high power system. And you can see I really have a lot of antennas there. But it's really the only solution we could find. Maybe there are better solutions, but nobody has come up with them. So as I said before, use low height sites, use low and medium powers, use simple antenna systems. Think about using more sites than may be necessary, which will bring you also other advantages. For example, your network will be more resilient, so you have a more overlapping coverage areas, and if one transmitter site fails, you will still have signal underneath from other transmitters. So better looking at more, I'm not pointing towards, let's say, a cellular network, but anyway, I suggest really a network which has more sites than might be needed actually. And another thing, and this is very important, is you really should go measure what you're building and gather also experience from your territory, because there are also, I mentioned this before, there is some magic in single frequency networks, and you will see signals popping up in places where maybe you didn't expect them, and even the software tools couldn't predict this. Two tricks we use basically in Italy. One is if you have a long flat areas, we use, let's say, what we call a procession. So we have basically a number of transmitters on a straight line, or let's say in the same orientation, and we build the antenna systems which will be more directional. So they will try to radiate only into one principal direction and they will not be omnidirectional. And this will avoid you, if you have very long distances, of course, to have to some delays and to avoid really interference. So you will have, let's say, a flow of signal going from one direction to another. And this is something we do, for example, on long coastlines where we are in risk of propagation over warm water. And so we take into account, if we look at the last transmitter, the eventuality that still the signal from the first one will arrive to this place. But we will build this transmitter here, transmitter number 4, in a way that it will not be able to travel back. So it will be, let's say, a single direction network. Another thing of course, you can do is, let's say, an umbrella type of network where you have a bigger transmitter in the middle, which has sort of omnidirectional pattern. And then you get smaller transmitters, gap fillers, you can call them, under this umbrella. In this case, the umbrella, of course, represents still our guard interval, and these sites need to be inside. If you look at all the models for DAB networks, they are very much thought on existing telecom networks. And these don't exist everywhere, where you have, let's say, a number of main cities and which are at a certain distance, like 60 kilometers. And in that case, you can put a big transmitter in each city. This is very theoretical. This is more practical. You have to adapt to what you have. Just looking a little bit at the problems, for example, we face in Italy with self interference, you can see we have, let's say, the colors represent a single frequency network. So we have a very long single frequency network on the east coast of Italy, which basically goes from the Alps down to the Mediterranean, to Sicily. This is like 1,500 kilometers coastline, if you look at this. And there are a few areas where you might see self-interference if you don't adopt mitigation measures, and which we have adopted, of course. So one is here in the flat areas in the north. You have issues here on the coast. Here you have a flat area which is very vast, and you have also to adopt, let's say, what I called before the procession. You have issues here over warm water, and you have also issues here on the west coast where you have signals traveling over water. And the problem is, although maybe it will be 10 days per year or 5 days per year or 1 day per year, you have to take this into account because once you have interference happening, basically your radio will become mute. Nothing will be receivable, and it will be very difficult also to identify which transmitter is creating the interference. So better plan in advance for this, be ready for this, and adopt these mitigation techniques, which might, as I said, they might sound simple, but they are very effective. As I said before, warm water propagation is very tricky and it's not easy to predict. Always take into account also the need to do some measurements and to get experience on the field. And you have also to adopt some choices. So if you look at the procession here, how will you build it? Will it go from north to south, from south to north, whatever? So you have to take some risk, take some decisions at the beginning, and then implement this. Just my last suggestion, and I will come to the end with this, really be ready also to take a step back, because sometimes really things will not go as expected. So plan also for, let's say, rolling back something. Not everything will be easy, but as we said before, the advantages are really significant, and therefore I really suggest you to plan for SFN, because SFN is magic. And that takes me to the end. Thank you very much. I hope I didn't overrun my time. And yeah, thank you very much.
Thanks, Hans. Thanks, Hans. Yes, that was a very comprehensive discussion on single frequency networks. So thank you very much for that, highlighting a number of issues, but also why they are so important and magic. I like that term. You got to have a little bit of magic. I think we'll run straight on to our next speaker, Lewis Grela, who's going to talk about the transmitters that you use in single frequency networks and how to make efficient and effective transmission systems. So please, Lewis, over to you now. Thank you. Please share your screen.
Okay, thank you, Les. Let me just share my screen first and let's go for it. Okay, so you see my presentation for the moment. Let me just see where I just go to the menu of the. You see my full screen now, or just a part of it?
We just see your presentation mode,
Yeah,
both sides. Just need to get the.
Yeah, I don't know where I just had to put it. I just did it before. Let me just go a second back. Okay, and I go in.
We don't see your screen now.
Yeah.
Just see your presentation mode there, but it's both sides
Yeah,
of the.
yeah. I just had before like another. What was the menu before? Sorry, just give me a second. Where was this duplicating? Yes.
Michelle, can you help at all here?
No, I just did it just before.
Yes, here. Yes.
Luis, it's up. Go up with the cursor.
Yeah. But you are seeing now my screen.
Yes.
No, it was on a different.
One of the buttons at the bottom.
No, it was before on a different. It was on a different menu that it was saying duplicate, so I don't have the two screens here. Oh my God! So I just did it 3 times.
Luis, do you see configuración de visualización on the top
Yeah,
of the
that's the one that I'm looking for to find, but I don't.
Because we see it
Where do you see it?
on the top of your screen. So probably it's not aligned your screen.
Where is that? I mean, just give me a second. Yeah, because it was exactly what I just wanted to do. And then I just had to do this. And there was a menu here that was showing before. That's it. Duplicar. That's it. So now it should go somewhere, yeah?
There we go.
Okay.
That's the one.
I'm done, yeah? Okay, so
Thank you.
so sorry for the beginning, but let's just start with the presentation. Okay, so my name is Luis Grela. I'm coming from the Spanish company TRedess, and in the next 15 minutes, more or less, my idea is to try to give an overview of how we, the different transmitter manufacturers, can somehow contribute to optimize the energy consumption on a DAB plus network. Okay, so the idea for the next minutes is to give I will just start with a very brief introduction for whoever does not really know us in depth, but then we will focus quite a lot on the energy efficiency topic with several aspects, how we, the different the transmitter manufacturers, can really optimize the consumption on the transmitter, focusing quite a lot on a particular topic about the MER versus efficiency. Okay, that's a topic that I will try to focus a little bit more on. And trying to also get to some conclusions, and we will also cover some ideas about the SFNs that connect quite a lot with what Hans Wolter has been sharing so far. Okay. So about us, we are a Spanish company specialized on DVB-T, T2, let's say TV and DAB plus transmitters. We count with around 28,000 transmitters deployed in more than 70 countries, and our portfolio covers more or less from very low power up to, let's say, 5 kilowatt transmitters. Okay. In the last 3-4 years, we have really become a relevant player in all these DAB plus kind of spectrum of projects, and we have delivered around 500 DAB plus transmitters already to more than 15 countries that more or less you see here: Spain, France, Croatia, Poland, Germany, Denmark. I mean, multiple projects that we have been deploying already. Yeah, we became a member of WorldDAB earlier this year. Okay, so we have been also participating in some of the SNIC conferences that Hans has been leading, and let's say trying to contribute as much as we can to the promotion and progress of DAB worldwide. This is just the typical panel about, let's say, partners, customers that we have around the world, just fitting the more or less this high number of transmitters that we have deployed there. And this is just a very easy map just to follow more or less what is the presence that we have in terms of transmitters. This is, let's say, focusing on the European market, but as you can see there in all these orange kind of dots, you can see that our presence here in terms of transmitters is quite significant. Okay, this is just an example of the case of France, where most of these are TV transmitters, but inside of this you have also around more than 250 DAB plus transmitters that we have been deploying in these previous phases of the national deployment there of the DAB plus technology. Okay. Also, other projects that we did in the eastern part of Europe. We have done also quite a lot of projects in the Asian part. Those were the DVB-T2 projects. Okay, the DAB plus is something that we are still yet to run over there, but we have done large projects in some of the countries that maybe you are attending the seminar from. Okay, Africa is the same, from Morocco, Tunisia, many countries we have done projects there. In terms of portfolio, low power transmitters, medium power transmitters, all accessory devices like GNSS receivers, satellite receivers, and all these for different kind of technologies. DAB plus, as we are talking today, DVB-T, T2, 5G broadcast, and so on. These are just pictures about low power transmitters, medium power transmitters, a 5 kilowatt transmitter in a single rack. Okay, so from low to medium to high, DAB plus, 5G broadcast, DVB-T2, that's basically what we do. Yeah. So focusing on the topic for today. Okay, so how we can really contribute to optimize the energy consumption on a transmitting side. So first of all, let's say that the Doherty technology is, let's say, something that we are everybody using nowadays as a standard. Okay, let's say that this is already quite clear. Just a specific remark on that. Okay, to highlight the advantage of using what is called the wideband Doherty. Okay, this is something that versus the narrow band, the wideband Doherty, what it brings is the capability that your amplifier is able to process all the DAB plus frequencies in just that same hardware. Okay, so basically that helps to optimize the number of spares, the operation of the network, and also the maintenance of the network. Okay, so the use of Doherty is clearly the element to start optimizing the energy consumption. Then making use of the most advanced transistors is also a key element. Okay, and here I have just a reference about what this technology has been progressing in the last years or decade or something like this. So if we think about, let's say, an older generation of transmitter where you were running with efficiencies of mid-20s, low 30s%, nowadays you can really reach efficiencies that are on the level of 50%, or even in some particular channels reaching figures of to 53%. Okay, so the jump is quite relevant, and this jump has some relevant impact in the operation of a network. Okay. Then another important way is of contributing on the energy consumption is try to bring this Doherty technology not just for high power transmitters, but also for the lower and medium power transmitters. Okay, so basically, we try to optimize as much as we can all the different levels and stages on the network. So if I go back to the numbers I mentioned before about, let's say, an older technology on DAB and a new technology that you can reach nowadays, and we put an example of a 2.4 kilowatt that I'm just showing here, basically here you can reach a figure about, let's say, just by optimizing a newer model, you can be saving around 42,000 kilowatts per hour. That in euros, if we estimate more or less 15 or 16 cents of euro per kilowatt per hour, you are saving around 67,000 euros per transmitter around 10 years time. Okay, so let's imagine a network where in the end we are counting with a certain number of transmitters, okay, of 2 kilowatt, 1 kilowatt, and 600 watts. So if we do this calculation based on this older technology or the newer technology, in this particular case, we are coming to the conclusion that we are saving a relevant amount of energy, hence almost €1 million in numbers of cost savings due to the energy optimization of the transmitter. If we go to a little bit larger network, okay, this figure really becomes much more significant even, okay? So even here I'm talking about, let's say, comparing an older technology versus a newer technology, and those numbers are also important to have into consideration when maybe you are thinking about renewing an existing network, okay? So if you are already having a network built with, let's say, older transmitters in that level of efficiency of 25–30%, these numbers can really trigger somehow the interest for you to start somehow renewing some of those higher power transmitters, because the savings you will get on the energy side will probably be quite significant for your cost of operation, okay? Then I jump also in other elements that are important to optimize when you are building a transmitter, okay? It's quite important to do a correct selection of the power supply, okay? This is quite a key element as well. Truth is that nowadays, if you think about all the main transmitter manufacturers, as Rode, Gateser, etc., we are all using more or less the same type of power supplies, okay? I just want to do another remark on this particular point, and is the fact that it's important also to make use of a power supply that is able somehow to maintain a high level of efficiency even when the power supply is not operating at the maximum load. What this will imply is that when you are not operating the transmitter to the maximum power, you also can get a good efficiency out of the power supply, hence also on the transmitter itself, okay? So the game here is, let's say, quite simple, okay? So try to make use of the best or the most advanced transistor, the best design of the Doherty circuitry around that transistor, and that gives you the maximum efficiency you can get out of the transmitter. And then it's a matter of trying to minimize how much you lose by processing that signal on the way of the transmitter, okay? And on that side, it's important also to optimize the energy consumption on all these different internal stages, like the control board, the pre-driver, the driver, the signal processing board, the design of the palette. Very important also the combining elements that put together the output of the different transistors, the different amplifiers, and also the control of the fans, okay? So basically here the idea is to try to avoid having any kind of unnecessary or over-dimension element in the transmitter. So to try to, let's say, reach at the output of the transmitter as much efficiency as you can, okay? And then I jump into another parameter that in the end is quite interesting here to mention, is about the MER versus the efficiency, okay? Those two parameters are directly related, okay? The higher you want to have one, the lower will have to be the other, Okay, there is no way to avoid this kind of compromise between both parameters. Okay, and in the same way as I would say that in all the TV projects we have been facing in the last 20 years, more or less the demand or the request from the broadcast network operators in terms of the MER has been always on a quite similar level, 33, 34, 35 dBs, some a little bit higher, but always more or less on the same range. It has not been the same on the DAB plus networks and projects, okay? So we have been getting some requests from broadcast network operators who really like to work with higher values of MER, 30, 34, 35, or even higher. Other broadcast network operators have really been defining the network to operate in MER of 26 dBs. And recently, what we have seen is even some of those who started operating in 26 dBs of MER are even thinking about, and have done tests and have done some initial implementations already on dropping the MER to lower 20s dBs, okay? 22, 23, 20 dBs or something like that. Okay, so it's a topic that in the end, the idea here is that there are like two different approaches for this, okay? People who really like to optimize the MER on the network, and people who really prefer to decrease a little bit the MER in a way that they can really optimize the efficiency and get some energy savings and cost savings on the operation of the network. So by collaborating with quite many of the network operators, as I mentioned before, we got more or less an overview of why people prefer the first option or the second. Okay, so more or less we come to the view that people who are, let's say, operating networks who are, let's say, not very large networks and not using very high powers, they don't see the point on really optimizing the efficiency versus the MER, okay? Because they don't see the advantage of, economically there, they don't see the advantage of really optimizing the efficiency, at least not in a very high figure, okay? Mainly because they are not using so many large number of high power transmitters. We have also seen the point of view that people using higher MERs see that they improve the efficiency of the SFN performance in complex mountainous areas, okay? Other people, they see the benefit of using higher MER when they are targeting indoor reception, okay? And in the end, they basically see that the robustness of the signal is getting better when they are targeting cars, and the cars are driving on higher speeds and targeting areas that are in overlap SFN zones, okay? And I didn't write it here, but another idea that people using higher MERs prefer to use those higher MERs is when they plan to use gap fillers as well, okay? Because the gap filler is going to hang from this initial transmitter, so the higher the MER, easier it is for the gap filler to operate later, okay? So those are the ideas, and Hans can share more ideas later on if he wants on that. But basically, those are the ideas that are, let's say, providing some of the broadcast network operators the interest to continue operating on a higher MER. On the other side, we have seen other broadcast network operators who have concluded, let's say, after doing their own tests, that their coverage and the quality of the signal on the reception side is not significantly affected by the fact of dropping the MER to, as I said before, 26 dBs or even lower. Yeah, and as they come to that conclusion, basically they really optimize the energy efficiency on the transmitters, because they really see the benefit on getting the cost saving on the network. Okay, those cases are generally related with larger networks, making use some of them of higher power transmitters. So clearly the benefits are already seen there from the economical and environmental point of view. Okay, so I think that in general we cannot say about who is right, who is wrong. I think that both approaches are totally right, and it clearly depends on each particular case what is more convenient or less to use. Okay. how is the network configuration, what is the powers that you use on the transmitter side, if you plan to use SFN or MFN, if you are targeting to do like a motorway coverage or maybe an indoor coverage inside of a city. So I would say that there is not a fixed rule for this, and depending on each case, each approach could have more or less impact, okay? So each P&O needs to analyze what is more convenient to them, and we as a transmitter manufacturer, the only way how we can contribute for this is to try to bring to them a tool that really makes a very easy process for them to play as well as or as much as they can with these two parameters, okay? So for example, from our side, I would say that one important thing that we can contribute with is already to have a very good performance on the adaptive pre-correction, because that brings already the MER into an optimum value. So no matter if in the end we are optimizing the energy by dropping the MER, we are already departing from the maximum MER we could already provide. Okay, so that is already a good departing point. But after that, what we have been providing to our customers is like an internal tool inside of the transmitter, what we call an algorithm for the optimization of the MER versus the efficiency. Okay, so basically on the web interface of the transmitter, you can really set up the target of MER that you really want to play with, okay, the minimum you really want to operate the network with, and the transmitter internally will be adjusting the voltages in the power supply in order to drop the MER from the original value to the value that you are really targeting to achieve. And on the other side, then the efficiency of the transmitter is increasing, okay? And by doing this, here, you can perfectly reach 3-4 points more of efficiency, or even in some cases a little even more, that really can be contributing a lot to the energy saving and also for the cost optimization of the network, okay? So for example, if I can, let me just show you a video. Are you seeing my video now, or you are seeing my screen with a kind of a video? Yeah, you see it now, yeah. Okay, so let's see this case. Okay, so I'm having here a transmitter that basically is transmitting with an MER of around 33 dBs, and I'm getting an efficiency of around 45%. Okay, so what I'm going to do now is in my web interface, I'm going to apply here the 26 dBs of MER as a target. Then I click apply, and then you will start to see that the MER, this is on the ETL, okay, so it starts to be optimized. So we are going from 37, I will just do it at fastest speed, okay? But basically you see that we are progressing from 37 to 36 to 34, 33, 30, 29, 26. So this is something automatically that the transmitter is doing, okay? And basically what we have achieved by this process is that we departed initially from an MER of 33 dBs and an efficiency of, I don't know how much it was at the beginning, like 45 or something like that. And basically we have reached a point where the MER has been dropping to 25.5, 26 dBs, and the efficiency is now on the level of 49.8. Okay, so this is a very easy tool that we can allow the VNOs to really operate the network with in a way that in the end can really help on the optimization of the consumption. And then let me just go back again to my presentation. Now you are seeing again the presentation on the full mode or just the slides?
It's not the full mode at the moment. It's gone back to what it was before. But Lewis, sorry, we're way over time, and I'm just thinking it'd be good if you could start to wrap up very soon, please.
Yeah. I will quickly on that. Okay. So
Thank you.
So if you want, I just continue in this mode as I don't find again there it is. Okay, there it is. It's just I'll just do it now. Okay, so the idea here is that when you are doing this energy optimization, you can really see that by increasing these 3 points from 50% to 53% that you can reach by optimizing the MER, basically you can reach also a significant saving. These are examples when we do the energy optimization on the networks that we saw before. Okay, so by just doing the energy optimization on the transmitter, by dropping the MER, you can really reach a significant number of euros that you can save. And just to go into less relevant but also important elements, basically here is that we can also bring some additional functionalities into the transmitter. Okay, so when you have on a transmitter side your satellite receiver, your GPS receiver, your monitoring tool, and the transmitter, basically here, if we bring all these functionalities inside of the transmitter, you can also save the cost of those elements plus the energy consumption of those elements that is embedded into the transmitter. Okay, so basically these are just satellite receivers built in, GNSS receivers built into the transmitter. The same for the monitoring tool. Okay, so if we have quite an enhanced monitoring tool inside of the transmitter, where you can see all the MER efficiencies, voltages, temperatures, and so on in a very good graphical way, and so on, as this transmitter can show here. Basically, you can also avoid to have additional elements on the side. Okay, so those are, let's say, just examples of savings that you can do there. Just as one of the last points here is about the use of gap fillers. Okay, Hans was talking about SFNs, and when you are talking about SFNs and you really want to extend the coverage, one important or very interesting way of extending the coverage on a DAB+ network is to use gap fillers. That basically what they do is that they just receive the signal from a main transmitter in RF and they just repeat it to this black area that is not being covered by this main transmitter. So in this kind of scenarios, you are needing less elements into the transmitting side. You don't need to have a satellite receiver, no GPSs, anything. So basically it saves also the energy. And all this is possible nowadays due to the improvement on the performance of the echo cancellation on the gap fillers as well. So nowadays it's perfectly possible to install gap fillers in 100 watts, and even I show you here a couple of examples that I will just pass through because the time is ticking, with 400 watts there. And just to finalize, another way that we can contribute to optimize the energy consumption is by providing you multiple architectures on the transmitters. Okay, so by the fact of maybe having like a multi-channel kind of solutions where you have an optimum cost and energy consumption per channel, because the other elements like the power supply, chassis, remote control, and so on is basically shared by the different transmitters, you are optimizing the system. Also, there are other solutions where they are called like multi-block, where you can process multiple channels in the same transmitter. As you can see here, you are taking out from the one single transmitter 4 different DAB channels, okay? And then just making compact solutions, bringing Doherty to the lower powers, having a very automated kind of process during the manufacturing process to increase the reliability, less problems, less visit to the sites. That will bring energy savings in terms of environmental aspects as well, and the same as a cost optimization in terms of operation and maintenance. Okay, so my conclusions, and with this I finish less. Basically, the energy consumption and energy efficiency has become a very important topic nowadays, mainly because of the cost optimization of the networks, internal company policies, and environmental aspects. So we, as transmitter manufacturers, can contribute to optimize all this by using Doherty, by bringing functionalities inside of the transmitter, by helping with the optimization of MER versus efficiency, by helping the networks to be able to come with gap fillers to extend the network in a much easier way, and basically by making reliable solutions that really help the operation and the maintenance of the transmitters. Okay, so with this, I'm done, and sorry for the initial problems with the connection, but I think that more or less it went right in the end.
Okay. Well, thank you very much, Lewis. There's very interesting, a lot of information there. We are now running about 25 minutes late, so we're going to do our best Remember, we can get these presentations. All these presentations are available after this this webinar finishes. We're now going to Arthur Ariiho of the Ugandan Communications Commission to talk about DAB in Uganda and what UCC is doing. So over to you, please, Arthur. Yeah, share your screen. That's it. Great. Can you get it into full screen mode? Can you get your presentation into full screen mode?
Hello, Doctor. Do you see it?
It's not full screen mode though. Can you put it into full screen mode, please? The little button at the bottom. Still not there.
Doctor, now?
I'm not seeing your screen now. That's it. Got it. Beautiful. Away we go. Thank you. Someone's got something on in the background, so please mute microphones.
Microphone. Okay.
Thank you. Carry on.
Okay, thank you, Doctor. So in the next 15 minutes, I'll just show you what we've done in Uganda in this technology. So I'll go to the broadcasting landscape, and this is pretty much the same situation across Africa, that prior to liberalization of the economy, we had a monopoly on broadcasting. So this situation changed with the liberalization of the economy, which allowed new players to come into the market, and through competition and innovation, we have a more competitive broadcasting sector. However, recently we've seen saturation of the FM band, requiring that we move digital so that we can accommodate more players in this field. I will not dwell on this because this is just the legal background why we're doing this. I think the rest of the members from yesterday to today have talked about what the benefits of DAB and also the specifications. This is being talked about over and over, but I will go straight to what the objectives of our pilot were. So we wanted to conduct technical evaluations and inform feasibility assessments, and also wanted the market to know that there is presence of this technology and its abilities, and also to inform our market on the necessary arrangements that we need to put in place in order to adopt this technology. So we piloted DAB Plus in Greater Kampala. Just this. These are the parameters that we have relied on. The previous speaker, Mr. Hans, talks about the low power transmitters, and I'm not sure if the 1.25 kilowatts is among that, but this is the whole setup that we had in Kampala. Just against these parameters is the prediction, the coverage prediction of what this would bring. So for this setup, we did the drive test to validate this model. What we've learned is that we need to harmonize the prediction with the drive test findings. So it's just a clutter. So what should people do in order to set up DAB? So from the pilot, we learned that we need to do a lot of stakeholder consultation in DSP. such that you have everybody on board. You have political buy-in, you have the market buy-in. So this is very critical in DSP introduction. Two, we are also setting up the baseline regulatory frameworks. And these include the licensing models, the receiver standards, transmission standards. Of course, these will also be consulted on with the stakeholders. And then we'll go to the coverage planning against the frameworks that we've set up. In this, we will set the minimum usable received strength. We will set the coverage parameters. So these are the baseline things that we're working on prior to adoption. So thank you, members. I hope you've seen what we're doing as a country this time. Thank you.
Thank you, Arthur. It's clear that Uganda is making some good steps forward and you're going down a good process and a clear process. Currently in the stage of regulation and licensing frameworks, as well as some other examinations and tests. So that's all good stuff. Very good. And very good to see Africa is moving forward with DAB in that fashion. So that's great. Okay, I think we'll move straight on now to Banda
Yes,
from
please.
the Banda Al Rasheedi from the Saudi radio broadcasting. So please, over to you, Banda, for your presentation. Thank you.
Thank you. It is my pleasure with you today to present the progress of and implementation of the DAB plus in across Kingdom of Saudi Arabia. And I would like to extend my thanks to Arab State Broadcasting Union, ASPO, and Asian Pacific Union, ABU, and World DAB organization for the opportunity to be on board event with you today. The DAB journey beginning in Riyadh, a pilot project in 2019. It's used 5-kilometer transmitter manufacturing by Redon Schwarz. This is the lead foundation of the project of DAB in Saudi Arabia. For be sure, there is a DAB receiver available in Saudi Arabia. We coordinate with the Saudi Standard Melody and Quality Organization, SASO, to lead all the car import in Saudi Arabia in 2024. It should we have a DAB receiver. We are extending the major city Jeddah and Dammam project in 2023. Each city has 5-kilometer gets air transmitter. And this is the first extend outside of the Riyadh area. In 2024, 5 more city, Neom, Hail, and Al Madinah, Al Ahsa, and Al Qasim region was active and used the transmitter from CIS. And each of the city are a separate head end. In 2025, currently the network expanded to the 9 more cities: Abha, Mecca, Taif, Al-Baha, Jazan, Skaka, Arar, Najran, and Tabuk. And this is linked by the centralized head end system in Riyadh. In 2025, following the discharge of His Royal Highness Crown Prince Mohammed bin Salman, 5 major projects are underway to coverage the Saudi major highway with DAB plus digital radio broadcasting. And the transmitter is a provider from the multi-vendor. And this project is using this project is implemented with the single frequency network technology, which is important for the safe spectrum efficiency and reduce the interface and provide a similar coverage along the highway. And this project will complete in the end of 2025. We installed the central head end in Riyadh. This will be connected central head end racks in Riyadh using VSAT technology. This is easy for connected for all the highway, and if there is any text or alarm or using for the emergency case to reach all different highways by using the GPS available in all transmitters. This is the conclusion for our project. Riyadh been on air since 2019. Jeddah and Dammam also is on air since 2023. The 5 cities also in air since 2024. The other project is still under implementation, and it is end of 2025. This is the coverage map in Saudi Arabia. You can see we are reach around 75% of population in Saudi Arabia, and we hope in our plan to cover around 90% of population in Saudi Arabia in the end of 2026. Thank you, and I hope it's clear for you.
Thank you very much, Banda. That was very interesting. It's I can see the a clear strategy there for your rollout, which is I think a very sensible one, and one that's used by other countries as well. We focus initially on the high population areas and then gradually bring in the highways that connect them, and then you go to the smaller populations after that. And a target of 90% by the end of next year of population coverage is, I think, a fantastic objective, considering that you only did Riyadh in 2019. So to get 90% population coverage in 7 years, that's will be an outstanding achievement. Okay, good stuff. Good stuff. I think we've had a lot of good aspects discussed today. We've got a number of Q&A questions as well. Some are answered and some are not. I think I'm just going to pick a few out because we've got a few minutes left. Maybe go over for a few minutes too. Some have gone on to Q&A and some have been in the chat. So I'm going to pick a few from various different sources. And the first one I'll address to Hans from Arthur. And the question is, it's one of a cost of single frequency networks. And the question is basically, if you settle for a smaller coverage area, won't you have to spend more on CapEx and OpEx? Hans, you are advocating for lower power transmissions rather than higher power. So that seems to suggest more sites, and which in turn suggests more CapEx and possibly OpEx. What are your thoughts on that?
Yeah, that is, of course, partially true. You will have a little bit higher costs. But on the other side, you will also have the advantage of limiting your interference. And so probably you will get a more coherent and more usable and more controlled coverage area. And the other advantage in this case is, as I mentioned before, you will have a more resilient network. So probably if one transmitter in this network fails, the others still will cover its coverage area or most of the coverage area, which means also you can build a network where instead of having a redundant transmitter in each site, you have only redundancy in the major sites, and maybe on the smaller sites, let's say you limit redundancy options and you save, let's say, a lot of capex from this point of view. Also, with the help of, let's say, the new transmitters like the ones from TRedess, from Luis, and other manufacturers, we are seeing a significant efficiency increase. And so, let's say, the additional cost is not so significant. So for us, it is well, it's also a necessity, of course, to keep the single frequency network running, but it's worth, let's say, the investment, because just to come back to the big transmitter sites, if you have only one big transmitter site, it becomes more vulnerable, and the other thing is you will have, let's say, a limitation in coverage. Last thing I add is if you have a more sparse network, you will have also a higher reception probability. So if I am looking at indoor coverage, we know that if you want to have a good DAB indoor coverage, you have to get to the windows. And if I have 3 transmitters in one city, the probability just that one window of the building or the room where the person is operating the radio faces the transmitter is higher than if I have only one transmitter site, of course. And this makes a significant difference. So yes, you'll have higher costs, but you will have also a more functional network, in my opinion.
Okay, that's good answers there, Hans. I'll add a little bit to it as well. When you're using high power transmitters, the extent of the interference into multi-frequency networks can be really quite significant as well. And that can actually limit the number of services that you're capable of delivering. And what we do know is in many countries, such as in Africa, through the GEO6 planning, only 8 frequency blocks have been allocated to DAB in many countries. And if you try to use high powers in those situations, you will find that you will be actually limited in the amount of coverage and the services that you actually deliver to people. So that's another reason to use a more dense network and a lower power network. Even though it might seem a bit more expensive because more sites, the trick, I think, is to find the sites which don't cost you too much, because, of course, the transmitter costs for these networks, like as Hans been talking about, smaller power is smaller cost. So you really have to weigh these things up over the long term. And I think Hans, like many other network operators, err on the side of quality reception. You don't want to, broadcasters don't like noisy and interference reception because it's interrupting their listeners. So they're the customers. So when you're providing a network, the customer's always right. It's the usual thing. Okay, thanks for that, Hans. I'm going to go give a question now to Lewis. And there's a question from Basil. Is there any correlation between the MER and SFN and MFN? Which one is affected more by a low MER? Can you answer that one, Lewis?
Yeah, I think that by the feedback, more or less, I have been getting from different network operators, when you are really operating in SFNs and there are some overlap zones, it's always better to have a better MER. Okay, and Hans can contribute a little bit more to that as well. But I think that basically, I think that that's the conclusion. When you're operating SFN, having a higher MER is always a good thing to have. Okay, another thing is how you want to play a little bit with the parameters. Okay, and basically there, if you really want to optimize a little bit more the efficiency, dropping a little bit more the MER. But I think that in the case of MFN is not so problematic, but in case of the SFN overlap zones, mountainous areas, that's where people have been really preferring to keep a little bit the MER a little bit higher than in other, let's say, easier cases to cover. Okay, I don't know from your experience, Hans, you more or less come to the same conclusion, or is a little bit different there in Italy?
Luis, no, I fully agree with you. The problem is there are some limitations in the planning tools which don't allow, let's say, easily to include MER into the network planning. So this is done more with measurements once the network is implemented. And what we see in, let's say, the pretty dense SFM network we are running is that the visibility and therefore also the quality and the persistency of the signals is evidently much higher if the MER is higher. And so we will see basically an increased coverage when we look at the higher MER. And this can be notable. I will not say it's very significant, but you notice it. And once you notice it, it's still something you have to take into account.
Okay.
So there is a connection between coverage and MER. And so,
okay.
Yes.
Okay, interesting. Very good. I'll just have a couple of quick other questions. I have one from Ibrahim Ashraf, who's talking about any plans to develop a dongle type receiver, USB-C, for example, to allow mobile phones to receive DAB+. Well, that was actually done about 10 years ago, particularly for iPhones. There was an iPhone dongle, came out of Taiwan, that worked quite well. I think I still have one in the cupboard somewhere. The trouble is what we found, and I was selling them at the time, so I sort of know, what we found was that people don't really like them. Oh, there's one there, look. People don't like to attach things to their phones. So they didn't sell very well, so they were withdrawn from sale after about a year. That may be different now. I think Hans is just showing us one then. Can you talk about the performance of that particular unit, Hans?
Sorry, I was muted.
Yeah, there we go.
I can tell you a lot because at that time I didn't own an iPhone, so I couldn't actually use it. The performance was only mediocre, let's say. Because of course antenna issues, etc., and chipset issues. I think this unit is at maybe even older than 10 years. I would say even 15 years. It still has
can see the sort of interface there.
Connector, so
yeah,
it's really old.
Very old. That was the same period that I was working.
Today there are much better chipsets, so maybe it would be possible to do a better dongle, but I don't know if there is any market for this.
Yeah.
Because
well,
once you have a mobile phone, you can also listen to other stuff instead of radio.
Sure. We do know that it's not hard to integrate chips into mobile phones. It's just having a source of phones for sale that will actually sell them. Telcos, for example, in Europe, do not like to sell phones with DAB+ because they think it is a threat to their data sales. That's the primary reason. It's not a technology problem. It is a business issue. All right, last question. We have a question from Nasser Al Mawali about automation systems and software integration with DAB and compatibility, for example, with Netgear, Dalit, and RCS automation systems. This is all regularly done. It's all standard practice these days. The audio comes out of the automation system in whatever form. It might be analog, it might be AES3, it might be Livewire, IP, AES67. It can all be it's all compatible with the DAB systems and the multiplexer systems in particular that are developed and provided today. So no issues there. Okay, we're about 10 minutes over, so I think I'll wrap now. I'll say thank you very much to our panelists today. Thank you, Hans. Thank you, Lewis. Thank you, Banda. And thank you, Arthur, for your excellent presentations. I think we've got a very broad scope of topics today, which was really useful to get. I'll remind that everybody can get those presentations off the website in a few hours, I think. Maybe this afternoon is probably more realistic. And the video of today will be available on Friday. We will also summarize all of the Q&A questions, even the ones that were answered online, and put that into some documentation so that everyone can see those questions and answers at a later date. That'll be available probably next week sometime, I'd say, by the time we've actually done the processing on that. So at this stage, I think thank you very much to all the audience for sticking around.
Everybody.
Again, a very good attendance and very good questions. Thank you for all your questions. And I hope to see you tomorrow, same time, same place, in the Zoom workplace.
Thank you so much.
And that's bye for now.
Have a good day.
And bye from everyone.
Bye.
Okay. Thank you.